Welcome to Microsoft Build 2017. My name is John Lamb, and I'm here to give you a tour of RTools 1.0 for Visual Studio 2017. Today we're going to see essentially two big things. The first is the data science workload in Visual Studio 2017, which is where you're going to be able to install RTools for Visual Studio, Python, as well as F#. The second thing that we're going to see today is what I call R everywhere. One of the great things about RTools in Visual Studio 2017 is our ability to connect to R running on Windows, R running on Azure VMs, as well as, and this is a work in progress I'm going to give you a sneak peek of, R running on Linux as well. So we're going to see all three of these things in the action-packed demo that follows. So we're going to go to the demo now, so let's switch over to the machine. Okay, what we're looking at here is the installer for Visual Studio 2017. One of the cool things about the installer in Visual 2017 are the workloads. New to Update 2 that we are releasing at Build is the data science workload. Inside the data science workload, you can see here that we have certainly R language support and RTools for Visual Studio installable via a checkbox, and we also have F# as well as Python support as well. The key thing about the workload is that it gives you everything that you need to get started using R, Python, or F#, including the runtimes and the libraries, in addition to the tooling that we put inside of Visual Studio. So typically what you'll do is you'll get Update 2 installed on your machine, you'll run the installer, you'll click on the data science workload, and you'll click on the install button in the bottom right corner. Now let's take a look at the tooling that we have inside of RTools for Visual Studio. New for our latest release, our 1.0 release, is this Workspaces window. The Workspaces window lets you see all of the different versions of R that you currently have installed locally on your machine. So as you can see here, we've started up Microsoft R Client. This is the version of R that we pre-package with Visual Studio 2017. It's a version of R that's produced and curated. It's a distribution of R that's curated and built by Microsoft. It also has a number of additional features inside of it, such as hardware accelerated computations for linear algebra subroutines as well. So we can see that when we're running the Microsoft version of R, that 3+3 here runs super fast, just like you would expect. The R interactive window is where you'll typically spend a lot of time interacting with the product. You can type lines of code inside of the window, and we will syntax color it. We will provide you with IntelliSense as well. So for example, if you wanted to install a package, you can see that as we type, you'll get the parameter IntelliSense appearing, and when you hit enter, it's going to execute the command and install the package locally in this case. Another place where you're going to spend a lot of time inside of RTools for Visual Studio is the editor window. So not surprisingly, we can in this case, let's just write a hello world function. So we can have hello world here. I'm going to type equals here. Equals is the way we do assignment inside of R, but it works. But typically R veterans would make fun of you if you type that. So we have this convenient shortcut where I press the equals key and I press the tab key afterwards, which transforms it into the assignment operator inside of R. You can see that the function keyword is colorized. Let's type a couple of parameters and some parentheses. You can see here that as I type a function name, we have IntelliSense as well as the parameter IntelliSense showing up for the function as you type. So let's type a string here. Let's say hello, name, comma, exclamation mark, and we even have parameter IntelliSense. So separator is a parameter, a named parameter for the paste function. And in this case, we pick that up and I can press tab here to complete it. And we're just going to say the separator character when I paste those three strings together is going to be the empty string. Another thing that you can do is you can select all of the text inside of inside of a range and press Control Enter. When I press Control Enter, it sends that text over to the interactive window and runs it. So now that we have done that, we can interactively execute it as well. So I can say hello to Windows, right? Because we're running all of this stuff on Windows. Now, One of the other really interesting things that we can now do inside of RTools for Visual Studio is switch over to running a different environment. Certainly we can do something simple, like we can run a different version of R running locally on my machine. So here I'm going to switch to the CRAN R interpreter, which is the same version of R that exists. So Microsoft always maps directly onto the latest version of R, modulo about 2 weeks. But we can run all versions of R, not just the Microsoft versions of R. Now, I can now show you this really interesting feature. So when I click on the little gear icon next to the Remote tab here, you can see that for the R on Azure entry, we can see that there's a connection string there that points to a virtual machine that is running on Azure. When I click on the arrow there, we're now going to go and connect to that virtual machine, log in using a set of cached credentials that we have on that machine, so that we can now start interacting with that. So what you can see below is that we have the name of the virtual machine that we're connecting to, as well as some information about the environment there. Where this becomes particularly interesting is, imagine that you were doing some model training locally on your machine using a downsampled version of your data set. You're typically doing this on a laptop for convenience so that you can work where you want. But of course, your laptop machine is optimized for battery power, so you don't have the same amount of compute power that you could get, for example, running on a machine inside of the cloud. So when the time comes for you to test or to train your model against a larger set of data or a full set of data, you can quickly switch to an Azure virtual machine. Perhaps in this case, we only have 2 cores here, but Azure virtual machines, you can have 32 cores, you can have ½ TB of RAM, lots more compute, lots more storage. Your large data sets could also be stored inside of Azure as well, so that the compute is next to the data. So you're just bringing the small program that you have, that you're writing, you're bringing it up to Azure, and then you can go run it there next to your data as well. And this can be particularly helpful for security and compliance reasons, where you don't want highly valuable data being stored on laptops that could be stolen or lost. So just like before, 3+3 runs just fine inside of Azure. So let's do something a little bit different here, where I'm going to now show you the debugger. So certainly all of the features that work locally inside of RTVS running against R running on your local machine in Windows will also run inside of Azure as well. So what I'm going to show you next is debugging. So over here inside of the say hello function, I can drop a breakpoint into there, and I can click on the Attach Debugger button, which will attach the Visual Studio Debugger to the remote Azure virtual machine. So once we have that up and running, I can now right-click here to source the R script on R. Because, of course, this is just a file that's sitting locally on my machine. This is going to go tell RTVS, hey, go upload that file up to the remote virtual machine, execute the code there, and now the code, that say hello function is now available for me to call. So I can say hello, and you notice here that I have IntelliSense there, so the say hello function is now known to RTVS, and I can pass a string called Azure to that function. And you can see here that I have the tooltips. I can see that I'm stopped here at this breakpoint. I have tooltips to show me the different parameters here. Note that I didn't pass a second parameter here because R allows you to have optional parameters. So let's continue execution, and let's call it again. But this time, we're going to pass in a data frame. And a data frame, of course, is the standard R data structure. And in this case, the data frame we're passing is the empty cars data frame, which is a bunch of sample data about cars. And if I hover over the df parameter inside of R, you can see these data tooltips appearing over here as well. And we have the ability to click on this and drill down into the structure of that interactively as you want. Another really useful feature that we have inside of RTVS is Variable Explorer, because empty cars is a data frame. A data frame is essentially a table of data, and it's terrible to look at a table of data by drilling down through an object hierarchy. So instead, we can look at that inside of Variable Explorer. One of the interesting features of Variable Explorer is I can now look at different scopes inside of my program. So in this case, I'm going to go switch my scope out of the global scope, which are where all my global variables would be defined, and I'm going to now look inside of the say hello function scope, which is where I'm currently stopped inside of the breakpoint here. And you can see that df, that parameter, shows up here. We can see that there's these 32 observations of variables. I can still do the same drilling down into it that I did before. But notice here that I can now click on this hourglass, and I can now see the data as a grid. I can sort. I can even do things like click on the Excel icon next to it, which will then take that data set and bring it down to Excel, so I can use the additional features in Excel to go and manipulate and slice and dice the data how I want. So that's pretty cool. We were just able to go off and write code against a machine running inside of Azure, debug that code just as if we were running locally on our machine. So you have this ability in RTVS to work both in an offline fashion against a local version of R installed, or in an online context attached to a remote Azure virtual machine. So let's stop debugging and let's show off this last thing that I wanted to show you today, which is a sneak preview of work that we are currently doing to enable connecting to R running on Linux. So what I'm going to show you here is I'm going to Alt-Tab over here to my, my console window, and you can see that what I've done is I've Docker run a Docker image that we have, and this is a publicly available image. And this Docker image contains all of the bits that are necessary to run R locally on your machine. So this container, this Docker container, is now running locally on my machine, and this command here will allow me to connect to that, that R on Linux Docker container that's running locally. So when I click over there, you'll see this dialog box appearing whenever you're connecting to a remote workspace that has a self-signed certificate, not a fully signed certificate. And this is very common in development scenarios. So I'm going to click on yes to continue the connecting. And you can see here that we're now connected to this version of R, right, which is running on Linux. You'll see some additional kind of work in progress. Apologies for our construction. We'll see a little bit of scary red text. We're working on getting all of that out by the time we ship the function. So all of the stuff that I showed you previously working in Windows and in Azure, everything working locally will also work remotely. We think about this Linux thing as just being a remote execution context. So something I haven't shown you yet is our plotting functionality inside of RTVS. So here I'm going to type plot empty cars, and that's going to go and generate a plot and in Linux and return the plot back to Windows to display inside of RTVS. I'll click here to create a new plot window, and I can go and do another plot of a different data set over in this. So we have this ability, because we have these great windows that can be dragged and dropped and docked around a different context inside of Visual Studio, so that you can visualize the data the way you want. You can even compare the visualization side by side if that's what you want to do as well. And certainly inside of multi-monitor systems where you have a second monitor or even a third monitor available to you, you can just as easily drag this window over to an additional monitor if you want to get or leverage the additional real estate that you would have there. So a couple more things that work just great inside of RTVS is, let's go back over here. I can now run this. I can source again this file, so that's going to bring it over to Linux and execute it. Now that I have that running, I can, from another file here, I can call the say hello function. You can see that we have IntelliSense being aware of the existence of that function, and I'm going to say hello to Linux now. So in this case, I'm just going to hit Control-Enter on this line, and we can see that we successfully ran that. A particularly cool feature that we have inside of RTVS is the ability to look at the definition of a function. So if I'm typing this code and I wanted to see what the implementation of say hello was, and I didn't know where it was, I can press Alt F12 here to bring up the peek code feature. So you can see that what RTVS has done is it's brought up an inline representation of the say hello function right in the code where I'm currently looking at inside of the editor. So again, all of the really rich functionality of RTVS is available, running on Windows, but in this case, connecting to code that's running on Linux. And this, of course, is super helpful for some of the libraries, a small number of libraries that only exist on Linux and not on Windows, or which perhaps have superior functionality on Linux versus Windows as well. Right? So you have the ability to run on Windows if you want, as well as on Linux. So let's switch back over to the slides. We're now done with the demo part of the talk. Let's recap what we saw today. Today, what we saw is in Visual Studio 2017 Update 2, you have the new data science workload functionality. So you just click on the data science workload and it will install everything that you need to start working with R, with Python, as well as F# inside of Visual Studio. I also gave you a quick tour of the R features that we have to support this vision of R everywhere. So we certainly saw connecting to different R environments running locally on Windows. We also saw some examples of connecting to an Azure virtual machine. And finally, we saw connecting to a Docker container running Linux locally on my machine as well. And as you can imagine, since we have the ability to connect to a remote Azure VM running Windows, we will also have the ability to take that same Docker container running Linux and run it up on Azure as well. So, what are the next steps? I highly encourage you to go download RTools 1.0 for Visual Studio 2017 with a data science workload. So remember, you have to have Update 2 installed in order to see this workload. The second thing is, of course, in this very brief overview video, there are many, many features that we haven't talked about, including SQL Server support, calling R in remote context, support for the Microsoft R client features. You will see detailed walkthroughs of all of that at our new documentation site at docs.microsoft.com. And we are also an open source project. Our source code and all of our development is done up on GitHub. So feel free to use our issue tracker to report bugs or to send feedback or feature requests back to the team. So I look forward to seeing all of your feedback and seeing the great things that you create using RTools 1.0 for Visual Studio 2017. Thank you.